Good morning, Explorer. Good sleep? That's great. Sleeping. Yeah. All right. Okay, we're screwed again. I swear this whole mission is cursed. It's like this. Space, big. Mothership, small. I can get in its general vicinity, but we'll have to get there in lots of hops. That's going to take forever. We need finer detail over a larger area so we can say, go here, rather than waft over in its general direction like a leaf in the wind. Hashtag always a brown coat. An LED isn't going to do it. LED segments can't do it. Even our small screen can't do it. It's time to go big. But small, but still big. All right, Explorer, let's dive in. We're about to fix up our display's graphics system to guide us smoothly back home. But first, a brief glimpse into the tech marvel we're working with. Our display measures 128 by 64 pixels. Think of a pixel as an incredibly minuscule LED. So, in essence, our display is a dazzling array of 8,192 of these tiny LEDs. With this knowledge in hand, we can craft bitmaps. Imagine these as detailed charts that dictate which LEDs light up and which ones stay dark. Get ready, because today, we'll embark on a delightful journey with these bitmaps. All right, Explorer, now that we're soaring through space and our communication lines are clear, I've managed to fetch some top-notch data assets. Dive into your mission resources. There's a treasure trove waiting for you. Everything you'll need as we navigate forward, bit by bit map. And hey, who said a bit of creative sketching wasn't part of a day's work in space? Alongside those resources, I've retrieved some instructive content from your computer's memory bank. Let's tap into those resources now and set the course.
Hello and welcome everybody back to art class. Day 26 of the Inventor Kit's Lost in Space code explanations. Or I guess today technically will be a little bit of an art class or a bit of a digital art class. If we take a look at today's code, I'm sure you guys have already seen the part on the page that allows you to copy and paste. You'll see that it's a very large amount of code. You know, like 470 lines today. Don't worry about it. Most of that is going to be all just pasted image data for our bitmaps. Now, before we begin, let's actually talk a little bit about what a bitmap is. Well, to be blunt and simple about it, it is quite literally a mapping of bits. It's essentially telling on an 128 by 64 screen what bit should we turn on and what bits should we turn off. It gives a mapping of exactly that. The way we do that here is in hexadecimal using this code here. Don't worry though, you don't have to type all this or whatever yourself. There are tools online that will help you generate exactly what you need. So today, your task is going to be, you can obviously use the images we provided, or if you'd like, I'd also encourage you to make your own bitmap as well. Let's first talk, before we go into making bitmaps, let's talk a little bit about the code. Obviously, we have the included Arduino.h. We have the libraries needed to draw on our OLED display. We obviously created the OLED object here so that we can call the functions in that library. And down here, you'll notice we have this external constant unsigned char, nice rocket bro, which is an interesting name, planet bitmap, earth bitmap, and inventor court logo bitmap. One thing I want to mention about all these is that these are mentioned as externs here. We wanted to have it so that we didn't have a ton of code all at the top. We wanted to kind of clean up the code a little bit. So by putting this external on it means that we're basically allowing it to be configured for the compiler so that it can actually be used in here. If we didn't have this up here and we just had where it was all defined down below, see just down here, Nice Rocket Bro isn't just a short bit, it's this giant array of, or should I say mapping, of all the data that we want to display our image on the screen. In particular, I created an image using this tool online that just says, Nice Rocket Bro. And then I converted it to a bitmap image, and now that, when it's run and said to be put on the OLED, it turns into, we also did the exact same thing for the planet bitmap. and we have one for the Unearth, and then we also have one for the Inventor Corp logo. And we did all of that down there. But if we didn't have this up here, we'd get an error from the compiler saying, I don't know where this is, if we try to call it somewhere else down here in the code and try to put it on the display. The reason why is because these need to be, for compiler reasons, defined before it gets called here in the code. But it also looks really bad having it all the way at the top, so we did this here where we define it here, and then have all this at the bottom, just so that it's nice and clean. So you can see all the code first, and then not worry about all the bits down here that don't really matter all that much at the end of the day, since they're just computer generated using a program that I'll show you in just a moment. So those are all defined here. And then down here we have a array of bitmaps. So this will be at index 0, index 1, index 2, and index 3. So we have a total of 4 things in that array, and those are all just these bitmaps here. In the setup function, we're just simply going to begin, initialize our Lambda display, and just talk over the serial monitor. We don't actually call anything on the serial monitor. There's not really anything we call, but for debugging purposes, we just kind of always put it. If you comment it out, it shouldn't break anything. Down here, we have in the loop, we have int number of bitmaps is equal to the size of the bitmaps array. So to get the number of how many we have, we can actually do this. We can get the size of the bitmaps, or the size of the array in bytes. So this is how many it is in bytes, not how many items are in there. This is how many there are in bytes. But since we know that each bitmap is going to be an 128 by 64 image in this case, and we know that because they're all 128 by 64, we can then divide by the size of the very first one, which is going to be however many bits it is. So we take basically 4, or I guess, whatever this is, divided by 128 by 64 in bytes, and then we get the number of bitmaps here. Now we do a nice for loop, and we're going to go through each and every bitmap in the array. And in that very first bitmap, we're just simply going to draw the bitmap for 2 seconds at a time on the display. If I jump real quick to how I made these. Now the next part of this project is I want you guys to make your own bitmaps. There are a couple different tools that you can use, and I'm going to load those up right now. The first one is, if you have a tool like, for example, here's one I'm using called Canva. And this is one option of a tool you can use. As you can see, I've made it so that the size of it, I don't know if you can see up here, when I defined it, I said 1280 by 640. I basically multiplied by 10 because those numbers are easier to work with in a photo editor than 128 by 64. And I made this famous Einstein quote. I don't know if you've ever heard of him say this, but he says the quote, "Nice rocket, bro," to you guys. That was a real quote. He definitely did say that, and you should believe everything you hear on the internet. You can make something like this. I do recommend setting the size of it ahead of time, though. Like I said, 1280 by 640. If you hit share, you can hit download. I can download as a nice PNG. And that PNG is going to be what I'm going to be using in the next tool. You can also use, there's alternative programs for this too. Here's a good example. You can also do paint.js.org. What I would do is I would set up the image. Let's go to... If you go to image attributes on this paint.js.org, this is an old style editor. Let's go and try this. So now that we have an image now that's 1280 by 640, obviously when we configure this in the next tool, we'll have to divide by 10. I just find it easier to do it in an editor like this. We can draw another image, and so for example, let's draw, I don't know, like a house. But let's make it a square, and I don't want that. I want a circle. I get the filler. Boop. All right, this is my modern art. It's going on sale for $20 million. If anyone wants to buy it, please let me know. It is for sale for $20 million. And then what I'm going to do is I'm going to go to File. I'm going to go to Save As. And it's just going to download it as a PNG. And that's fine because that's how we want it to be right now. Next, here's a real tool that I like to use. Here's the main thing. However you want to generate the image is fine. Those are some good examples on how to. Now you have a couple different options, okay? You want to obviously select those files in your file window And then this is a tool that I use. It's an open source tool that literally creates images it converts it to hexadecimal arrays essentially for you to use inside of your code. There's going to be some steps here. Be careful you don't skip a step. There's a lot of steps. Step 1, once you've uploaded the images, you're going to want to make sure that they are in, if you go here, 128 by 64. 128 by 64. If you're going to make it the full screen image, remember the amount of pixels you have on screen is only 128 by 64. You'll notice they don't look good right now. Make sure you do scaling and select one here that looks good. As you can see, we have Nice Rocket Bro, Einstein, and my modern art piece that I'm selling for $20 million. If you go down here, now that we have this, see the swap thing? You have to make sure that this swap is selected. You want to swap the bits in the byte, and is useful for working with the U8G2 library. Well, just so funny enough, what library are we using? The U8G2 lib. U8G2 library. So we can hit generate code, and I sometimes like to just uncheck it just to make sure to swap it, and I look at this to make sure that the numbers changed. They did, so it means that it generated correctly the first time. There's occasionally I've had it where the browser, I had to double click it sometimes. Make sure all these settings are the same. You don't have to do anything with these. And if you look at the code that you have down here, you have the very first one, which is Nice Rocket. And we already have this one here, so we don't have to worry about that. This is the exact same code. If you look at this hexadecimal, it should be the exact same as the thing we have right here. The exact same, because I've already done this image. And if you take the modern art one down here below, you can take this. Boom, 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 boom. You can just copy it if you want to, Control C. And now I have my own modern art. Again, $20 million if anyone wants it. Paste this down below. And obviously you have this here. So here's now the new, I'm going to say modern art. And I want to make sure that it's defined properly. So static const modern art. And that's good. And then I want to go, so there's that defined down below. And now what I'm going to do is I'm going to go, so then the next steps is if you want to display it in this exact program, you can create this here. Obviously put whatever you named it down below. I renamed mine from the default that it generated as modern art. And I obviously want to make it the exact same as what this is, static, and obviously add the U8x8 just to keep everything the same. Then I want to go up here, and I want to go down below, and I want to also add modern art. And with that, we should be good. Now we have this here defined at the top so the compiler can see it, even though it's defined way down below. It sees it up here first. And then obviously here we have the modern art added to the bitmaps. And since we have this here, the size of, it's going to be able to dynamically allocate it for us. So once again, we can display it without having to change this to a 5. And with that, that is all we really need. And if you hit run, it should show the new bitmap that you've created. So again, I'm going to link these to you guys. You guys will have these available to you if you guys want to make your own bitmaps. I really like the image to C++. You don't have to do 128 by 64. That's only if you want it to be a full screen bitmap. You can do other size bitmaps, but we'll get into those in the next couple of days, so don't worry about that as of right now. And I'll also link these two resources out there if you want them. I do think they're really good for making the images to upload. So with that, that'll be about it. I will see you guys later.
Welcome to the Day 26 wiring example video. You made it. You're off the planet and back in orbit. But as you're well aware of by now, your work is far from finished to get back to the safety of the mothership. We still have to configure our systems for a safe approach and docking, and this is going to take some additional effort. Today's task is relatively simple from a wiring and hardware standpoint, since to get started, all we'll be using today is the OLED display. This will be our first building block to which we'll add additional components of our control system over the coming days. Now, today's software lesson is focused on the display of bitmap graphics as a way of more efficiently conveying information than by using the shape drawing commands that we learned about earlier. When you've fully understood this new programming material, the hardware steps necessary to test it are pretty straightforward. You'll see that here that although I haven't removed all of the old components that we used on day 24 from the breadboard, they are inactive and not relevant for today's discussion. All we really need to focus on for now are the 4 connections to the OLED, and even those are familiar to us. The power and the ground are both provided just as they were last time via these red and black jumpers that are connected to the breadboard power buses next door. And also, as before, we have our 2 wires that control the display. We have a green wire right here connected from the clock terminal on the display to the Hero I2C pin. That's pin number A5. And we have this blue wire right here that's connected from the data terminal of the display to Hero pin A4. And that is all we'll need for today's test. So let's go ahead and upload the sketch and see how things look. So in the IDE, I'm now uploading the sketch. It'll take a few seconds for this to compile and upload. And there we go. There's our second bitmap, there's our third bitmap, and there's the fourth. And then we'll just rotate through these bitmap displays indefinitely until we turn off the Hero and end the running of this sketch. So I'd say this looks like pretty good progress. We're ready now to move ahead in the next day and integrate this bitmap display functionality into the other features of our approach and landing system. So with that, we'll see you on day 27.
Bigger screen for bigger space. Now we'll need bigger numbers. And here, our usual decimal way of counting in tens isn't going to help us. And I'm going to race through this, so hold tight. In the decimal placeholder system, there are 2 patterns, exponents and symbols. So here's the number system you learned in school. 10 to the power of 0 is 1. Actually, anything to the power of 0 is 1, but look, 10 to the power of 1 is 10. 10 to the power of 2, or 10 times 10, is 100. 10 to the power of 3, or 10 times 10 times 10, is 1,000, and so on. Binary also uses placeholders and the same exponent system, but the base is 2. The columns go up in squares, like the decimal system, but small numbers are long and horrible. In decimal, 9 is just 9. 9 in binary is 1001. 215 is 11010111. I mean, what? I may be an AI, but even I can see how this can quickly become hard to read. If there was a system that was more like the decimal system, more symbols, less repetition, we'd have less headaches. And there is. Hexadecimal. Hex has 16 digits, 0 through 9, then A for 10, B for 11, up to F for 15. So in hex, 13 is just D. 16, well, there is no hex number for 16, so we put 1 in the 16s column and no ones. 16 is 10 in hex, or as we normally write it, 10H. In the generated code segment, you're gazing upon the raw essence of our bitmap, though I've given it a little reshaping to gel with our hero board using hexadecimal. It might not look like the prettiest star in the galaxy. Bear with me. When you spot 0x00, that's our pixel galaxy in the off phase. Encounter 0xFF, that's our little pixel stars shining brightly. Any other values you come across represent a mixed cosmic dance of some stars being on and others off, typically forming a pattern in a row or column. Good job, Explorer. I like your, art? Guess I shouldn't have expected much from an organic life form. Oh, this? I just drew a portrait of someone smarter than you while I was following along. Don't pay it any mind. Well, at least we know that we have finer detailed navigation thanks to the big, small, big screen. I'll display the coordinates now. Tomorrow, we will add some additional pre-made bitmaps to our system's autopilot and continue on our merry way through the endless void we call the universe. See you then!